Hello everyone, welcome to Echelon channel. So today we are going to discuss the second method of finding the rank, which is a very easy method and popular method. So this method is known as row echelon form. So whatever you need to pronounce, you can pronounce. Some people will say it as a row echelon form. Some will say as a row echelon form. So it is up to you. So this is according to me, it is row echelon form. Okay, so this is one of the easiest method of finding rank. So you cannot expect a essay question from this one. I'm not sure, but you cannot expect, because since it is a easy one, everyone will do this. So you can expect a 2-mark question from this topic. Okay, but don't blame me if you get any essay question from this topic. So I will clarify the concept clearly to you. It is your duty. Either you get essay 1 or a 2-mark question, you have to solve that. Okay, so first let us see the statement of this row echelon form. So what is it saying? The number of zeros before any non-zero elements in a row should be less than number of such zeros in the next row. So what is the first statement? It is saying that the number of zeros before any non-zero elements in a row. So when you consider a row, there will be some non-zero element. Non-zero element means nothing but which is not zero. So before that particular element, before that particular non-zero element, you will have a zero. So such zeros should be less than the number of such zeros. Such zeros in the sense the zeros which are present before non-zero elements should be less than in the next row. So it should be less than this count should be less than the count in the next row. So don't get confused. I am going to explain you with a clear example. You will get an idea about that. So this is our first statement. And what is the second statement it is stating means? So if there are any zero rows, suppose consider if there are any zero rows, it means the entire row is a zero. Make them as a last row by elementary transformation. So zero rows, if there are any zero rows present in a matrix, then it must be a last row. When you consider it as a row echelon form, you must make it as a last row. Then now the main thing is how to find the rank. So that means it is saying that rank of given matrix is number of non-zero rows in row echelon form. So once you convert it into a row echelon form, then number of non-zeros present in that row echelon form is our rank. So don't be confused by simply listening to the statements. No one will understand by listening to the statement. I'll explain you with an example, then you will get the complete clarity on what is meant by row echelon form. Then again you have to go through these statements, then you will get 100% clarity. That is my guarantee. Okay, consider these examples. I have taken a matrix as 1 2 3 0 4 5 0 0 6. I need to verify whether this matrix is in row echelon form or not. So what is the first statement of row echelon form? So it was saying that number of zeros before any non-zero element. So number of zeros before any non-zero element in a row. So I am considering this row. This is a non-zero element for me. The number of zeros before this element is, how many number of zeros I have? 1. Should be less than number of such zeros, means which here we have another non-zero element. Before this non-zero element, how many zeros we have? 2 zeros. These zeros, the count of these zeros should be less than the count of these zeros, which is 2. Then only if this condition gets satisfied, then we are going to say that this matrix is in row echelon form. So clearly you can see here we have only 1 zero and here we have 2 zeros. Obviously 1 is less than 2. So now you can say that the matrix A is in row echelon form. So this was the first statement. Now you read the statement again. Number of zeros before any non-zero elements in a row should be less than number of such zeros in the next row. Okay, now you would have got 80 to 90% of the clarity. If we discuss more examples, you will get 100% of the clarity. Now consider this matrix. So indirectly, what is row echelon form saying? If you observe clearly, this is our diagonal, principal diagonal. So below the principal diagonal we are having all zeros. So you can say that upper triangular matrix. So row echelon form is nothing but you have to convert a given matrix in upper triangular matrix. That is our row echelon form. So very simple. You just have to observe the things. You have to grasp the things. That is when is it possible means when you have focus on the video, when you have focus on what I am saying, and when you are clear in the subject, when you have good knowledge on the subject, then you will observe these things. Row echelon form is nothing but it is a upper triangular matrix. So converting into row echelon form is nothing but converting into upper triangular matrix. Okay, now let us take this example. I have taken a matrix B. So how many number of zeros you have before non-zero element? You have 2 zeros. Similarly, in the next row, how many zeros you have? 2. So can you say that 2 is less than 2? Obviously no, it is a crime if you say so. So 2 is not less than 2 is not less than 2. So this is not row echelon form. This is not row echelon form. Now consider this matrix C. So what is it happening? What is this matrix C saying? Number of zeros before non-zero elements. Here we have 2 zeros, and here we have no non-zero elements, but we have 3 zeros. Obviously 2 is less than 3. So you can say this is row echelon form. Or you can also simply conclude by the statement that row echelon form is a upper triangular matrix. I said right. So this is our principal diagonal. So below principal diagonal elements all are 0. So this is also upper triangular matrix, which indirectly indicates that it is in row echelon form. Now if you talk about the ranks, so this is row echelon form. So in row echelon form, what is our rank? So rank is nothing but number of non-zero rows. 0 row means nothing but entire elements of a row must be 0. So do you see any such kind of rows here? No, right? So that is why rank of A is nothing but 3 here. Okay, since there are no non-zero rows. When you consider this one, this is not even in row echelon form. You have to do it by using normal form, or you can do it by shortcut. Okay, now here it is a row echelon form, but you have one zero row here, 1 0 row, and 2 non-zero rows. Okay, so what is rank of A here? Rank of C, sorry. What is rank of C? Number of non-zero rows. How many non-zero rows you have? 2. So rank of C is 2. So this is our row echelon form, and how to find the rank of using row echelon form. Now let us discuss a example. So you are given this matrix and you are asked to find the rank of this matrix A by using row echelon form. So see, my suggestion is, whenever you are asked to find out the rank, what you have to do is you make this A11. A11 is nothing but element present in first column. Whenever I say A11, you must be clear with that. Okay, A11 in the sense I am talking about the element which is present in the first row and first column. Okay, make A11 as 1. Make A11 equals to 1. This is my suggestion, not mandatory, but in the normal form it was mandatory. But here this is optional, but I would suggest to make this as 1. Okay, after making this as 1, you have to convert this given matrix. This is the 4 by 4 matrix in upper triangular matrix. You know right how an upper triangular matrix will be. So when you consider diagonal elements, so below this principal diagonal all elements must be 0. Okay, now my aim is I will make this R2 as R2 plus 2R1, then R3 as R3 minus R1. Okay, then how my matrix is going to get converted? 1 2 3 minus 1 I have, then R2 minus 2R1 in the sense R2 plus 2R1. So minus 2 plus 2 0, minus 1 plus 4, I guess, right? R2 plus 2R1, minus 1 plus 4, yeah, minus 1 plus 4, it is 3. And how about this one? Minus 3 plus 6, this is also 3. Minus 1 plus of this will become minus 3, I guess. Minus 1 plus 2 into minus 1, that is minus 2. So minus 1 minus 2 minus 3. Okay, so this is minus 3. R3 plus R3 minus R1, 1 minus 1 0. Okay, then how about 0 minus 2, then this is minus 2. 1 minus 3 minus 2. 1 minus of minus 1, it is plus 2. Okay, yeah, we are getting some sort of pattern here. Okay, let me see what this will be. This is 0 1 1 minus 1. Now what I will do is I am going to multiply R2 as R2 by 3, and I am going to change R3 as R3 by minus 2. Let me see what will this happen. 1 2 3 minus 1 we have here. R2 by 3, 0 1 1 minus 1, R3 by minus 2, 0 1 1 minus 1. Okay, 0 1 1 minus 1. Okay, we got certain pattern here. Okay, now what I will do is I will subtract R2 from R4 and R3 from R4. Okay, what I am doing is R2 implies R2 minus R4. Then what I am doing is R3 implies R3 minus R4. You should observe each and every step carefully. Why I am doing like this? Do you have any idea? You need to get this kind of doubts. See, if I do R2 minus R4 and R3 minus R4, I am getting this. I'll get this entire. I'll make this entire rows as 0. If you are getting entire rows as 0, that is a big advantage for you. You will simply convert it into a upper triangular matrix. That is why I am doing like this. Okay, now what I will get, how this matrix will be converted after this step. It is going to converted as 1 2 3 minus 1, R2 minus R4 in the sense 0 0 minus 0, 1 minus 1 0, 1 minus 1 0, minus 1 minus of minus 1 minus 1 plus 1 0, R3 minus R4. Again this also it will be converted like this, 0 1 1 minus 1 I have. What I will do is I will shift this row here and I will shift I'll interchange these two rows, R2 interchanged with R4. This is also my one of the elementary transformation. Then how my matrix will get converted, 1 2 3 minus 1, then 0 1 1 minus 1. Why this row is has got changed into this? Because R2 I am interchanging with R4, exchanging. Okay, now I have 0 R3 as it is, and in the place of R4 I have R2. So now if you consider the diagonal, principal diagonal, okay, if you consider this principal diagonal, so what are the elements before below this principal diagonal? Every element is 0, so you can simply say that this is an upper triangular matrix. Okay, now upper triangular matrix is nothing but our row echelon form. So inside the row echelon form, what is the rank? So rank is nothing but number of non-zero rows. You have only two non-zero rows, 1 and 2. These two are 0 rows. So the number of non-zero rows is rank in row echelon form. So rank of given matrix A is equals to how much? It is 2. So this is how you are going to find rank using row echelon form. It is very simple form. Okay, whatever kind of matrix you get, you can simply convert that into row echelon form. Row echelon form nothing but it is an upper triangular matrix. So how do you convert in upper triangular matrix? Since I have got some pattern over here, I converted these two rows into 0 simply. If I had not got certain pattern like this, what would you have done? So you have to convert. See, first of all, what you have to do is you have to make this element 1, then you have to make these elements as 0 by using only, see, the thing in the row echelon form is only row operations are allowed, only row. That is why the name has become row echelon form. Only row operations are allowed. You can't do column operations in the row echelon form. Now what I am saying, what I was saying, yeah. Okay, now you have to make these elements as 0 first by using row operations. Then what, by with the help of R1. Okay, R2 plus 2 R1, then R3 minus R1. Here it is already a 0. I did not do any kind of operation. Then what you have to do, you have to make these two elements as 0. So nothing but upper triangular matrix you are going to make. Then what you have to do, first these elements as 0, these elements as next these two elements, next this element, only by using row operations. Very simple one. I need not explain you in the like the previous one. I explained you in step by step. Right? And there is no need of explaining in step by step. Only upper triangular matrix. Converting the upper triangular matrix is your goal. You can do it however you want. Okay. Yeah, that's it about row echelon form. These are the two methods which we have in the syllabus for finding out the rank. Hope you got some clarity. Not some clarity, you would have got the total clarity on these two methods. Still, if anyone is having doubts regarding these two methods and regarding our particular examples which are discussed in these videos, you can not text me, you can do comments. I'll be seeing your comments. Okay, then thank you, and don't forget to like the video as well as share the video. Okay, thank you for watching. We'll catch you up in the next video.